Okay, good morning, good afternoon, good evening, wherever you are in different parts of the world. You want to put on your video, you can do that, Peter. I'm going to make you a presenter as well. Okay, so it's up to you. I'm just going to say hello to everybody. That's about it.
Hello, everyone.
Okay, great. So this is fun. Oh, look at all those beautiful stars you have on your slide. Oh, okay. So this is good. So we are here now today to have an excellent webinar planned for you. It's about questions and answers. Yeah, and as Peter will tell you, that's how the name of the company that he belongs to, Quanser, came from the two words questions and answers. So Peter is an engineering education specialist who has been a member of the Quanser R&D team for 10 years. As a senior R&D manager academic, Peter is responsible for the vision, strategy, and management of the academic team and product owner for core educational platforms and products, including software applications, curriculum, and mobile applications. Peter currently manages several project teams developing the next generation of virtual and remote lab platforms and the Quanser robotics manipulator. Um, Peter is also heavily involved in product marketing and technical sales. Before starting at Quanser, he was at the University of Toronto, and tells me once he was a Spider-Man for a summer. So thank you for joining us all the way from cold Canada. I hear lots of snow there. So over to you, Peter.
Thanks very much. My pleasure. I'll just turn off my camera to save bandwidth
Sure.
here.
Yeah, I can
All
off
right,
too.
perfect. So thank you very much, everyone. It's nice to be here today. I appreciate you coming to listen once again to us talk about what we do. Today's going to be a little bit different in that you may have heard other presentations that I've given where we talk sort of more about new innovative products that we've developed or ways that we can use our products for different applications. This is a little bit different because what I wanted to do today was to dive a little bit into how we create the platforms that we create, how we've sort of developed an approach philosophically, if not in terms of how we design and develop these products over the last 30 years. Hopefully, my goal would be that you can take a little bit away from that presentation to possibly create platforms or products that you think would benefit your students in your particular field of expertise. Especially, I'll talk quite a lot given what I do at Quanser about our academic content and how we design and develop and create academic content. And hopefully, again, that will be helpful in terms of how maybe that can be adopted by you in your practice. And so, yeah, without further ado, we'll get right into some of the questions that we think about when we develop content and products, and hopefully some of the answers. So the first thing I'll start by doing is talking about this question. This is one that I almost always like to start my presentations with because it's something that we really think about quite a lot, to be honest, especially when we develop new products, which is how do institutions prepare students to succeed in this modern era? This slide, funnily enough, is probably almost out of date already from when I created it last year because technology is always, as we know, changing at a breakneck speed. The problems that are faced by engineering teams around the world are completely different year to year, even month to month. And so the challenge of giving a content experience, an educational experience to engineering students is ever changing because the skills they need, the approaches, the thought processes, the intuition is completely different when from year to year, from cohort to cohort, trying to prepare them to be able to succeed. And so this is something that we try to do, is to not necessarily make our platforms and our content appeal directly to current issues or current trends or technologies. Obviously, that's part of it, but I think a lot of it is creating platforms and creating experiences for students that are lasting, that have either a general impact or that can be adopted for different emerging techniques and different emerging problems, and something that's a little bit flexible and gives students, again, like that intuition, that idea of how they can approach these problems, how they can apply the skills they're learning in the real world to really be effective. And so with that, you would think, that the ideal engineering lab, as we see it, would be something like this. Just an electric car sitting in the middle of your lab, and students get to take it apart and see how it works and experience what it's like to build an electric car. And that isn't necessarily an experience that would not be idealized. That's an experience that would be fantastic if anyone could pull it off. But there are a lot of problems with that kind of approach. First of all, it's not necessarily accessible to a lot of institutions. You don't necessarily have the funds or the space or the infrastructure to be able to park a vehicle in the middle of your engineering lab. And at the same time, a lot of the experiences students would have working on that would be very hyper specific to that industry. They'd probably be very complicated, might not necessarily be scaffolded properly so that students could really have the skills and take away those experiences that they need to succeed in whatever field they want to pursue, whether it be industry or research. And so I would posit that this isn't necessarily the ideal engineering lab. The answer to this question is not this. And so obviously you'd then knowing perhaps who we are as a company, think that this would be our example of an ideal engineering lab filled with our equipment. And obviously I wouldn't very adamantly disagree. That I would get a lot of feedback from marketing if I did, but I think probably philosophically we would say that this is the ideal kind of experience for students to have from an engineering perspective. Not necessarily, like I said, with this exact complement of experiences or products or things like that, but more so having an experience that's accessible, that they can have a nicely generalized or appropriate experience, something that's still authentic, that's still real to the kinds of experiences that they would see in the real world, but something that they can actually interact with, understand, maybe even see some nuance in and things like that. So there's a real sort of scale, a real spectrum of experiences that students can have in between that actually working on real systems, real vehicles in quote unquote the real world, or having these kind of abstracted experiences, these kind of representative experiences. And so that kind of spectrum is what I'm going to talk about a little bit today, as well as you'll hear some of the keywords that I've been peppering through my conversation to kind of pinpoint exactly what our goals are and exactly how we can kind of tune both these platforms and these experiences to be able to provide those goals and have those goals fulfilled by students. And another question from that might be, how did we come up with these ideas? Why is this little company in Canada one that that has these thoughts on engineering education? And so I'll just briefly digress a little bit into who we are. So 30 years ago, we started developing platforms to be able to more effectively teach, at that time, control systems primarily. You can see here our first product that we developed back in the late 80s to give students a hands-on experience with how control systems worked. And you can see through the years, we've refined our platforms quite a lot here. You can see the progression of this family of servo motors. Not necessarily, as you can see, changing the physical systems a lot. Obviously, there's different experiences now. Nowadays, with our more modern systems, we've sort of started to build them more compact. We're starting to sort of integrate them and make them a more easy to use, accessible platform. But more so, the content has also changed and surrounded these with really rich and vibrant experiences for students to have. You can see here our current iteration of this kind of progression of servo motors, the cube servo, and this one, I'm not necessarily excited to tell people about it because it's a servo motor, but I'm excited to tell people about it because we have over 40 student experiences that they can have learning everything there is to know about control systems and mechatronics and how this system works and how it can be an analog to all sorts of other experiences in the real world. And that's kind of the direction we've come in and why we have these notions about how platforms can really inform and can really build experiences for students that are lasting and that are exciting for them, despite it just ostensibly being a servo that that moves back and forth. There's a lot going on, and there's a lot that it can be used to show. And this is another example which we developed last year, primarily in response to students not necessarily being able to have those hands-on experience, which is a completely virtual rendition of this system with the same experiences, if not more heightened and more intricate experiences and kind of hybrid situations or even sort of augmented reality kind of experiences. So there's a lot that you can give students around a simple motor that can give them a lot to think about and a lot to really take away from these experiences, whether it's applying it to controls or applying it to other emerging fields like IoT or machine learning. There's a lot that can happen. And so what we try to do, as you can see, is to build a platform, build something that's not just a piece of hardware, but has more rich, kind of almost an ecosystem around it. This is one that my team developed this past year. And what we used to do, again, talking a little bit about the history, is we would aim for these goals. This would sort of be our way to get to that high level target that we set in terms of being able to prepare students for the modern world. We would try to make sure that they worked reliably, they weren't going to break down, they were repeatable so that everyone behaved the same way. They were somewhat flexible in terms of being able to interface to different sorts of platforms. They were open architecture, so we're not hiding anything. You can dive deep into how it works and see the sorts of underlying processes that are going on. And obviously, like I said, a rich surrounding set of courseware to be able to give students those sort of educational experiences. And so this is, you may guess where I'm going with this. This is what we used to do. And what I would posit, at least based on the way that my team and I have been thinking about these sorts of platforms over the last year or two, especially developing this one, the QArm, is that maybe that doesn't necessarily address our goals. It doesn't necessarily address that high level goal of preparing students for modern engineering and also providing platforms that can really be effective. And especially as you can imagine, as the world changes rapidly, we have to adapt our goals. We have to adapt the way that we create products to make sure that they can do what they need to do in order to give both our partners and their students the right kind of experience using the product. And so what I've done is I've taken our platforms and our approach and I've broken it down into two different sets of goals. One primarily based on teaching and one primarily based on research, because as much as there is a lot of overlap, there is sometimes some benefit in approaching them from the two different perspectives and then trying to blend those to find a common ground that is really the right combination of techniques and skills and capabilities for both of those different approaches to how people use a platform. So for teaching content, again, you'll see here some of the words I've been using. I think our goals are primarily to be able to build content that's academically appropriate. So by that, I mean content that is right for where students are when they use it, whether it's in first year or fourth year or postdoctoral graduate students. It's an appropriate experience for them to be able to see not just how something works and understand the tools and techniques that are at play, but really be able to understand how that could apply to their own future use cases, be able to understand what's going on in terms of complexity, in terms of the nuance of how systems function. So it has to be appropriate for them academically. It has to be efficient academically, and that's a little bit of a fun word to use. Efficiency in this case really means that it can be deployed effectively without too much wasted effort or infrastructure or requirements on an institution to be able to have a platform like this in their facilities or even virtually and have students able to use it effectively. So that sort of gets into things like accessibility and the way that you can use this effectively for multiple courses and things like that. And then finally, authenticity. That's a really big one for me. Authenticity, I think, is very, very important because that leads directly into what I see as being the first and foremost concern when building content, which is motivation. To me, authenticity is hand in hand with motivation, where authenticity is basically the experiences that students have using these platforms and going through this content is authentic to the sorts of problems, the sorts of experiences they would have, again, in their future lives, whether it be in research or in industry or wherever they find themselves. We want those experiences to be authentic, to have a nugget of truth in how students approach these problems and the sorts of problems that they're given. I had a lot of experience, not a lot of experience, but I had a couple of occasions when I was in undergraduate studies years and years, decades now ago, and you lost that authenticity and immediately you would lose the course. Like the problems we'd be given would be along the lines of, you have an egg that needs to be transported somewhere using vacuum parts, and I'm just like what are we doing this for? This is not a problem anyone is ever going to have again. And so being able to have that kind of motivation through an authentic experience is very important to keep students engaged with the content and engaged with the platform. And then finally, what we try to do out of these experiences with these goals is to build intuition. That's especially important with design, because especially in design courses, we're not necessarily trying to give students the answer to every design problem, but build intuition so that they understand what to consider when they're faced with a design problem, and therefore what some of the answers might be. And literacy, where literacy isn't necessarily knowing all of the answers or everything there is to know about a topic, whether it's controls or robotics or whatever, but being able to talk about it, being able to understand what experts mean when they talk about different concepts or theories, and what's at play, especially nowadays when people are generalists. It's really important to be able to talk to a team of experts and understand their concerns, understand what they're referring to when they talk about the nitty gritty, deep, dark depths of a particular topic. And then obviously gain useful skills. That's always something that is imperative to be able to approach modern problems. And then next, in terms of research platforms, again, research platforms are a little bit different in terms of what's the main goal that we have when we build a platform. The first would be to obviously accelerate research. We want to give researchers, especially to a certain extent, graduate students, the ability to get to a valid point, get to the implementation of their theories and their concepts quickly, because as you'll see later on when I talk more about this concept, the longer it takes, the more drawn out a research project is, the more at risk it is for not necessarily bearing successful outcomes. Flexibility, because we never know how things are going to be used. And then longevity, again, because as they're used for different projects, for different cohorts and generations of students, we want to make sure that they're going to last and they're going to be useful for long periods of time. So getting into teaching, I think we'll start there. The first thing that I wanted to do to kind of bridge the gap between the content we create and these goals that we have was to start with the modern student. Who is the modern student that we have a goal to be able to equip for these modern times? Modern engineering students, and I got a lot of these terms not necessarily out of my head, but talking to colleagues who've been teaching at various universities recently. They're connected. Obviously, we all know that. That's something that's sort of a given now, especially over the last decade or so, in terms of how connectivity and mobility has really permeated everything that is part of a student's life. But they're also motivated. They see around them these exciting engineering things that are going on, just like we had in that first slide, rocket ships and drones and all sorts of amazing things around them. And so they're motivated and excited to be able to be a part of that, to be able to give back to that community and be able to have those experiences, which makes them a little bit impatient. They want to get there. They want to see the finish line. They want to have their career in place and ready to work on self-driving cars or self-driving drones or all sorts of things like that. And because of that, a lot of times, again, it all comes back to motivation. All comes back to being able to provide to students a motivational experience, motivational content that primes them, that really prepares them to have meaningful and lasting experiences. So meaningful being experiences that they can see the benefit, they can see the trade-off of their investment of time and energy, and lasting because it then hopefully the ultimate goal starts to inform how they see their future, basically not just seeing how it could relate to what they want to do in the future, but possibly even change what they want to do in the future to align to repeated experiences, more exposure to a particular field. And that's exactly what we try to do. We try to give students experiences that show them robotics, show them control systems and mechatronics in a way that might change their career path. That's the ultimate goal, is to prepare students for these sorts of challenges. And so how do we do that? How do we, let's say, decompose an engineering experience and try to tune it to be able to provide those goals? So what I've done here is I've taken engineering education in abstract, and I've tried to look at the sorts of content experiences that we try to build for students. And I've mentioned a little bit up until now how there's kind of a spectrum in terms of how industrially relevant or accurate an experience is, how complex it is in terms of the very basics, introductions to a concept, something that could be like a user manual, all the way through to something that could actually be using an industrial system. And then how realistic it is in terms of the sorts of problems and issues and techniques that are used that might be used in their real world, whether it's whatever they choose to be or something a little bit more abstract. And so if we look at that sort of space around these experiences and where these sorts of experiences fall on that spectrum, again, starting with motivation is really at the heart of that. It's right in the center of an industrial experience where students can see a glimmer of what might be done with these types of approaches in the future. But it's not too hobby level. It's not too sort of aligned to something that they would do in their basement or in their spare time. There's some not necessarily industrial, but some engineering at play. There's some complexity from the engineering basis for it. It's more than just plug and play. There's a lot going on and they can understand that and see that. And that sort of bleeds into complexity again, where the experience is complex enough that it's appropriate for academia. It has that theoretical foundation, but it's not too overly complex or overly problematic in terms of how difficult these challenges are, how sort of the scaffolding is there to be able to reinforce those experiences. And then finally, in terms of realism, it's right at the heart of a realistic experience where it's not too real in terms of they're going to run into problems and run into obstacles that will prevent them from being able to be successful. But at the same time, it's not, like I said, completely invented. It's something that has some truth to it. That's where I see the heart of motivation, which really is the catalyst to all of these types of experience. And so, like I said, in terms of industrial alignment, if it's too industrial or too hobbyist, it's too much on the outer edges of what really makes a motivational experience. If it's too realistic, then it basically is not really theoretically sound. It's too hands-on. And if it's too theoretical, then again, it loses that motivation because a lot of times, especially for students, theory isn't where their excitement lies. And then finally, in terms of complexity, if it's too complicated, then it becomes very difficult to use. If it's too simple, then again, students will lose interest because it's more like reading a user manual than actually getting an experience. And so it's that spectrum and that balance that we try to find, so that, again, as I said, they can see the payoff. They can see how this experience will really help them. And so starting with motivation as kind of that catalyst, that critical piece that every experience needs to have, then we can sort of take these different spectrums, these different elements, and we can basically combine them into a single spectrum, a single kind of optimization problem, from something that's very basic, like a user manual, to something that's very real world, like a co-op experience, and try to see how we can take some other metrics out of this to be able to try to give an experience that achieves all of our goals and reinforces that element of motivation. And so first, talking about value, this really comes down to, again, when will students use this experience again? What are the essential skills they need to have? Is there something a little bit generalized that they can use for wherever they find themselves? And so, as you can see here, in the way that we see this, the value of an experience really increases as you get towards that center, that balance point. And then, as I said, in the extremes, just like you would imagine, it sort of falls away a little bit. And I'll give you an example. Let's say that you have a challenge for students that's based around beer brewing. That you might think ostensibly would be exciting for students, might be really motivational. Like that's something that for a lot of students they're interested in. But at the same time, if it's too simplified, if it's too small scale and theoretical, then there's no engineering at work. There's no educational value there. It's the same sort of thing you would do in your backyard or in your basement without any formal training. But if it's too industrially accurate, if you're actually using a full fluid control system with PLCs and all the intricacies at work in a real brewery, it's not necessarily too complex, though it probably is, or too practical, but it's also very difficult for students to take that experience and reuse it themselves. And if it becomes too hyper focused on a topic, then they don't see their personal interest, their personal motivation at work there. And so what we try to do in that middle ground, you can see here with something like our couple tanks, would be to give almost like a case study with analogous academically appropriate examples where students can see a glimmer of the real world, but it's appropriate to their skill level, it's appropriate to the sorts of general challenges that they could see at work in other types of scenarios. So it's that balance point right in the middle where they can still see the motivation, but not lose the value of the experience to them personally. And then the last thing I'll mention is accessibility. So in terms of accessibility, again, you take those three metrics, and in this particular case, being able to have a student actually experience this in an academic setting where they gain their intuition, they have the right skills to be able to approach these problems. Instructors can actually deliver these experiences academically, whether it be on or off campus. This is something that's really important because it doesn't matter how exciting and fantastic a platform or educational content is. If students can't understand it or they can't get access to it, then it's useless. And so if you look at this in terms of an example, let's say self-driving vehicles. Again, very exciting for students, something that a lot of students are really interested in, especially nowadays. On the full spectrum on the left there, you can see if it's too simplified, too non-industrially focused, too kind of abstract or theoretical, it's basically reading a textbook about self-driving. And as much as that is very accessible, that's the peak of accessibility, is reading a textbook or a PDF. There's no real, you start to lose the other elements of it. You start to lose the value and lose the motivation. Whereas if you go too much on the other extreme, where it's a very industrial, very complicated, and very realistic, hands-on, practical experience, then at that point, you're basically operating an electric vehicle. You're basically using it, and that's not very accessible. Not, like I said at the very beginning, most institutions, most students don't have access to take apart and understand the inner workings of an actual self-driving vehicle. And so, again, there's a balance there. And you can see here, obviously, we would try to move towards the left-hand side of this experience. We would try to kind of get over into this area where we have max accessibility. But the problem with that is you need to think about it in terms of the layers of this experience. So if we put on top of this the element of value, and we put on top of this the element of motivation, you can see it is actually kind of this area that we're trying to focus on. It's this area of, again, the middle ground, where it's a balance of industry, a balance of complexity, and a balance of realism, where there's kind of that golden arc, whatever you want to call it, of experience where students get lots of motivation, they have access and the right tools and the right preparation to be able to have that experience, and it's valuable to them. They can see where they'll be able to have that experience be useful again in the future. So some of the key considerations that come out of this, some of the questions that we ask ourselves when we build these experiences are, first and foremost, when will students use these skills and knowledge again? That's something I ask my team all the time. It's like, this is great. I understand that a lot of times we want to dive into how a brush DC motor works, but when will a student ever need to know how a brush DC motor works again in this context? Are they ever going to need this particular piece of knowledge or this experience again? And again, like, what do they need to know? What is the core that we want to really focus on and really make sure that students pay attention to? Do they understand the application? Do they see that payoff? Do they see that that value? Can the platform or the content be efficiently deployed? Can students have this experience? And then finally, is it authentic? Is it one that has that nugget of truth? And so through this, you can see the value, you can see the accessibility, and you can see the motivation. And ultimately, we try to make sure, answering this last question, that students take away skills and experiences that really motivate them for their future investment in a field. Like I said, we really want them to see where they could go with some of these experiences and how they could use them themselves and how it could change the path of what they do. And so looking at that now from the research side, from the other side of the coin, in terms of how these platforms prepare students and how these platforms can give students a better experience in their academic life, I'm going to go back again to the ideal lab. And you can see here, this is a slightly different lab experience. In this case, the question is this the ideal research lab? You can see here, there's a lot of very complicated, very specialized looking equipment. These researchers are obviously very well versed in what they're doing. They have a lot of equipment here that looks very expensive, that's filled this room, that theoretically should be ready for them to work on their platforms. But part of the challenge becomes, if they were required to build all of this equipment, how long did that take? How many issues and problems that they've run into? If this is going to live on in this space for years to come, then what? Who's going to maintain it? Who understands how it functions and how it can be modified to future research efforts? And so what I did to think about how we can sort of idealize this research experience was to start by looking at my experience in graduate school and my friends and colleagues who've been through graduate experiences, and kind of break it down into this kind of year by year focus on two different elements of the actual researcher themselves, one being their motivation and one being their level of fatigue, both very important when it comes to research. Again, this is idealized mostly to a 4-year graduate experience. But if you look at that 4-year experience, let's say working on a doctorate in engineering, then your first year is primarily based around research. You're trying to get to know your field, to understand the problem that you're looking at. And as you can see here, the motivation level is a little bit shallow because reading papers is not necessarily all that exciting. It isn't why people come to do a doctorate most of the time. And also the fatigue level increases quite a lot, not necessarily because reading papers isn't exciting, but more so because at the end of their first year experience, especially in North America, there's that committee meeting. There's that that sort of like justification for why your project has value. At my institution, that was called a deck. At a lot of institutions, it's called quals or things like that. There's always some element of a committee meeting, often, at least in North America, where you need to sorry, lost my audio there for a second. There's that element of why you need to justify that first year and your direction. From there, then you can see the motivation takes off, because then you're in the heart of the research. At that point, you're really going full force into your academic experience, your research experience. But at the same time, you can see the fatigue level also continues to rise, because that's a lot of work. That's the heart of the research, where you develop and validate those concepts. And then at the end of your third year, you have that pivotal experience where it works. You see the result, you see the functionality, and everything comes together. And at that point, you're like, in your mind, at least as a researcher, you're kind of finished. Like this, you've done what you came to do, and the rest is just documentation. The rest, where the motivation kind of declines because documentation takes a long time and there's always more work and more iteration than you expected. It's not necessarily as tiring as you might think, depending on how much you enjoy writing. But basically, the critical point comes at the end, where the question is, have you finished? Have you graduated? There's always a little uptick right before you finish, in terms of you're almost there, you're almost finished, and that's in and of itself motivational. But there's a lot of again, fatigue continues to rise the longer you're there. And if it extends a little bit too long, if your motivation sort of continues to fall because you just want to finish and you've been there forever, then you can have this critical experience where all of a sudden, all that's left is being tired. You're done, but you're not done. Like you're finished, you want to just leave. And that's happened with a lot of my friends and colleagues in research, where they're right at the end of their doctorate experience, especially, they just kind of are ready to leave, and there's not a lot left. And that can happen at any point. It doesn't have to happen at the end. I had one colleague that I worked with who, after his first year, right around this point, just never came back. He was like, no, I'm just not interested. His fatigue level went up far too quickly, and his motivation was never really going up to start with. And so he just kind of never came back again. And that's the critical point that we hope that we can try to help avoid, is that keeping students motivated to their research, making sure that we try to take away some of their fatigue, take away some of the elements of a research experience that might be tiring, and at the same time try to obviously make an experience more successful. So how does that happen? Looking at this graph, you can see that what I've done is we've condensed the develop and validate into just a 1-year experience, where hopefully you can see here, if the first year research, there's not a lot we can help with. First year research is what it is, but hopefully there's a little bit more gratification in terms of knowing that things should function because these systems are already in place that will do what needs to get done. But then especially in that second year, being able to develop and validate these approaches much more quickly, because we have a lot of the examples, we have a lot of the foundation in place, we have the ability to reuse existing approaches. Our platforms are flexible, but at the same time, we build a lot of underlying frameworks in place to be able to support and take away some of the bugs or obstacles. And so the goal is to be able to develop and validate more efficiently, more quickly, to condense this middle area so that you can get to being validated much more quickly. And that can avoid, again, the creep of being tired and fatigued of doing the work. Also, obviously, you can try to bring this lower to try to make the energy required to build something and validate it a little bit lower. And so hopefully you never get to that point. You never get to the level where all that's left is being tired. And so that's what we try to do with our platforms. It's a strange way of looking at it, but to me, that's the main concern, is trying to make a platform that is as useful as possible to be able to just implement and validate research as quickly, like fast track your research to being completed and validated, so that the level of effort that goes into that is minimized as much as possible. And the other element to it, as I mentioned, is the longevity of the platform. Building a platform for research like that one you saw at the beginning, again, the main question is, do you have stacks and stacks of user manuals like these to have all the documentation and procedures and maintenance requirements and support techniques for this platform? Or does none of that exist and it was sort of developed by a student who's now gone and no one really knows how it works or how it could be modified? Again, I have a lot of experiences like that in labs that I worked in, where someone developed a platform for either for their research or for the laboratory that we were working in, and then they left, and maybe their documentation is there, maybe not. Hopefully someone understands how it was built, but not necessarily. If it breaks, who do you talk to? That one of my previous positions that Krishna mentioned at the beginning was being full-time on staff just to maintain systems like this. And so there's a lot of training, a lot of documentation, a lot of maintenance, and that's where we try to kind of, again, help as a company, because we can do that training, we can build that documentation, and so that way it's all there, it's all ready, it's all fully in place. And whether it's maintenance procedures or support or everything, we try to make systems that can live on, that can have that longevity, where people can use them again and again and again, not just because they have flexibility and expandability and reliability to be able to accommodate future projects, but also because they can actually be used in the future. So let's give a couple of examples of that. The first example I'll give is the development of the QArm. That's something that I was able to be lucky enough to manage that project. So I'm familiar with how we applied some of these techniques to building that platform. And so if you look at it, the first thing we did on the left-hand side here was try to make it, like I said, flexible enough for multiple future research projects. So what you can see inside that base, you can't necessarily see it from the front, but we have the same flexible interfacing that a lot of our products have, where it can be used with embedded computers, it can be used with just a USB connection to any PC, and it has the ability to use a variety of interfacing techniques to be able to, again, make it flexible and adaptable for the future. And also, as you can see on the right-hand side there, we decided to go with smart instrumented joints, not just DC motors with gearing in each joint, but actual smart servos that have their own embedded computers with a whole spectrum of control options or instrumentation options, again, to kind of instill that flexibility, that adaptability into the platform so that it can be used for all sorts of different current or future applications. In terms of being able to, again, make it a little bit more adaptable, we added a camera system to it to be able to do emerging fields of inquiry, both for teaching and research, things like machine learning and all sorts of other applications of vision, of to be able to to be able to see what's going around and adapt to it, and then it's expandable and adaptable interfacing to add and modify these systems, again, for research or for capstone projects, for student design projects, always kind of trying to think about how we can give these experiences to students right in the middle of that spectrum, but also make a platform at the same time that can be used for different types of research applications. So trying to find that balance between all of them. And then finally, a little bit in terms of accessibility. On the left-hand side here, you can see we developed a digital twin to go alongside the physical system to try to make sure that it's accessible, that if students aren't on campus or they don't necessarily have the budget to be able to teach with more than one or two physical systems, every student can have their own virtual system. And then depending on the teaching accessibility, in terms of the platforms that students want to, or professors want to use for their syllabus, or students want to use for their research, being able to apply it to lots of different platforms, from Python to MATLAB, Simulink, .NET, ROS, all the different common approaches, and also industrially relevant approaches to how you would talk to a manipulator. So we can see there is a little bit about the physical system, how we instilled some of these goals, some of these motivations to try to make it flexible, to make it adaptable, to make it industrially in mind in terms of authenticity, but not necessarily, but also academically appropriate in terms of how easy it is to use and how it can be scaffolded. You can build experiences, everything from a first year or a community college level all the way up to a graduate level course. You can have an experience on a platform like this that can run that full spectrum while still being accessible and still being the right level of complexity. And then when it comes to the content on the other side, the teaching content, again, we started with this philosophy of application. So again, starting with motivation, how do systems like this work, generally speaking, in terms of a manipulator? So you can see there in the middle, there's the arm itself with the dynamics and statics going on. There's joint control, there's kinematics to understand how the arm is behaving, path planning to understand where it's going, imaging systems to augment that experience, and differential kinematics to understand how it's moving as it progresses from point to point. And so we looked at this sort of breakdown of the manipulator system, and we layered the experiences on top of it. But as we layered those experiences on top of it, again, we tried to focus on what are the elements that have that grain of industrially relevant balance, that grain of balanced complexity, where you can see here, we're not just teaching differential kinematics, we're teaching it under the context of tool manipulation. We're not just teaching inverse kinematics, we're teaching it in the context of a teach pendant. So we're sort of trying to layer the actual application, layer how you would use this technique on top of the actual theoretical foundation. And not only that, but also scaffolding these experiences in terms of accessibility, so that on the outside here, you can see we have a full complement of experiences at the very beginning of understanding how robotics works, from lead through to teach pendant to trajectory generation to just basic interacting with the system. But then as complexity increases, we build those experiences, getting into more complex approaches to manipulation, and then all the way through to things like machine learning and digital twinning and adaptive control in the center, where at that point, all of those outer layers have kind of built to the point where that complexity is able to increase. And so that kind of shows how a lot of the thinking in terms of both teaching and research comes together for us when we develop a platform and develop something that we think can be used in academia. And the other example I'll give you is just a very quick example that you may have seen from us before, but again, it's one that I was very familiar with how we developed it. And in this case, I think it really idealizes the teaching approach. This was how we developed a lot of these concepts and thoughts I've been talking about today in terms of the philosophy of how we build these teaching experiences, and that's experience controls. What experience controls was, it was essentially a concept we had for wanting to build a textbook that had all of those elements I talked about. So a textbook that would give students an accessible experience and one that was motivational, that had a good level of complexity and a good level of industrially relevant content. And you can see here it's completely mobile. Students can carry it around on their phone or on their tablet. And we built everything around these interactive real world examples, analog experiences where they can see the control systems come alive. We surrounded it with podcasts, with a whole lot of content, check your understanding questions, things like that, that all kind of make sure that that level of complexity is there, the level of understanding is there. But at the same time, they're all built around those interactive experiences on a phone or a tablet where students are used to being able to see content, to understand how content works. They're interactive, so they can understand the payoff, the downstream effectiveness. And it was completely free, the ultimate level of accessibility. It's on Android, iOS, nowadays on Chromebooks, and increasingly on Mac OS as well. And completely free for students, completely free for instructors. So trying to be able to give that experience where this kind of approach, this kind of content experience can be something that students have, and something that hopefully, like I said, has that downstream benefit to them no matter what path they take. And this was very successful, which is again why we continue to develop some of these philosophical thoughts around how our content should be generally, because this, I think now we're well over 7,000 students who've used this platform, with hundreds of reviews from students saying like, this is fantastic, we've loved this experience, which I never thought I would get as in terms of creating engineering content, that kind of level of excitement from students. So it was very gratifying. And because of that, it was something that we tried to replicate as much as possible with how we approach content and how we approach our other platforms. And again, in closing, that's kind of something that is the last question that you might be thinking about is, that's great for Quanser. It's great for me to talk about these techniques from coming from a company where we have a large dedicated team that only does content, that only does academic applications and academic curriculum day in and day out for years, with time and investment from our corporation, and without really any limit on what we can do. Like, we don't need to worry necessarily about accreditation or any of the other elements of what goes into the typical content, the typical course material that is used at an institution. And so I understand that. We've, a lot of my team and myself included, have taught at universities. We know what it's like on when you try to create experiences that are cutting edge and exciting like this at an institution. And so basically, what the only sort of answer I have to that is that hopefully we can use this material to help. That's all we really want to do with these sorts of content experiences, these sorts of platforms, is like understand that yes, we're privileged to be able to develop these experiences, develop these platforms, but hopefully through that we can help you get there faster, get there more efficiently, and understand how these experiences can help your students and help your researchers. And with that, I'll open it up to any other questions.
All right. Wow, that's quite a lot of thinking that went into that. Amazing. I really loved the fact that motivation was at the core of everything. That's really very, very critical, I guess. So I'm going to open it up to
every document we write now for our curriculum team. We start with a motivation section. Like that's the beginning of every document.
That's something I guess as teachers we should always be keeping in front of our minds. So what is it that we're doing that's really going to build motivation among the students to learn on their own? So that's great. So open up for questions, folks. We have a little time to do that. Let's see if anybody wants to jump in. We have Ala with us and Hans. Ala, you want to make any comments that now that you're up here? Yeah.
Sure. Yeah. Thank you, Peter. Wonderful presentation. And like Krishna said, the thought that goes into developing the platform and so on is quite impressive, because it really addresses the learning right on. I just have a question. You know, in this day and age of remote, distance learning and online learning and so on, one thing that you've done that is very effective is to have a digital twin for your product. Another approach is to have, very low cost platforms that students could actually purchase and use at home, because in this case they do still have the hardware to work with, but maybe it doesn't have all the features. Have you put in any thought into having a line of products like this?
In terms of how we put thought into it, absolutely. We've been thinking about that challenge for as long as I've been at Quanser. Unfortunately, because as almost like a catch-22 to your previous point about how much thought and effort we put into these platforms, and how large a team we have of very qualified both academic and industrial engineers, it's so difficult to have that be cost effective for us. Like, you can imagine that like the digital twin you mentioned, our virtual experiences, that was 17 full-time R&D engineers for months and months and months working on that platform. And for that experience to be the right balance for a private company to be able to make that investment and have the scale of students using it be a trade-off that makes financial sense is very, very challenging, especially when it comes to hardware. So it continues to be a challenge. I think we'd love to be able to do that, to give students the ability to have these kinds of hands-on experiences at home, exactly like you said, especially not just now with students being at home increasingly, because universities around the world have been closing, but also because even before that, with the emergence of online courses, the MOOCs and things like that, being able to give students hands-on experiences at that scale would be fantastic. That would be a wonderful thing to be able to do, but it's such a challenge to be able to do that with the level of fidelity and the right experience and the right level of quality that we try to achieve as a company. It's a very difficult thing to do cost effectively. So I think I would just say that continues to be a challenge.
Peter, I had a question about you had the concept of motivation and fatigue. Yeah, and very interesting balancing of the two, and you focus largely on the graduate education that after for a PhD program. Now, if I were to think about the same concept of motivation and fatigue in the undergraduate 4 years, what would you come up with if you started analyzing it that way?
That's interesting. I hadn't actually thought about that. To me, undergraduate is really interesting because I think it's almost a U shape where students come in and they're hyper motivated. They're super excited to be at university, to be quote unquote engineers, and to be like gaining all of these really exciting experiences. And then it's, at least in my experience in second year especially, but also to a certain extent third year, there's the realization of like engineering is not easy and university and academia is not easy, and whether or not you were successful in secondary school, it doesn't necessarily mean you're going to be successful as an engineer. And so there's always that dip, probably both in motivation and definitely in fatigue, right around second and third year. But then I think it does come back up again in terms of once you get into the later university levels, you scaffolded your knowledge and your experience to the point where you can take on the challenges, but also probably started to specialize in things that are inherently motivational and exciting. At least that was my experience. And so it follows that U or that V shape of motivation, but obviously it's always tiring. University engineering is always tiring. The hope is just that the motivation can increase in order to keep up.
Yeah, I mean, it'd be interesting to see if if you can understand that cycle of motivation and fatigue in the first 4 years and use that actually for design of curriculum and activities for students, so they really get the most out of their 4 years. A question here from the audience, but Harish Kumar says something about industrial-based service and product-based service. I mean, product-based. I don't know if that question makes sense to you, but take a shot at it anyway. Industrial based on service and product based. Harish and Karsh, can you elaborate a little bit more on that? I'm not sure I understand what you're trying to ask. Let's see, any other comments, questions here?
One of the things that I'll mention just really quickly on the closing topic I had of hopefully with our time and effort we've put in over the decades to these types of platforms, we can help everyone as much as possible. Is I'd be remiss if I didn't mention that my colleague Pasha will be giving a webinar next week, I believe, on how we can help with grant proposal processes. And so that's another area where we have a lot of experience over the past few decades of helping our partners with grant proposals and to secure grant funding and things like that. So that's another area where we have some expertise. We can hopefully help everyone, and he'll be talking more about that in the next week or two.
So Peter, you did mention that you had thousands of students who have tried out your this, your the what you have to offer, the service that you have to offer, and they're really excited about it. Now, these were all postgraduate students?
No, these are all undergraduate students.
Undergraduate students. Ah.
Yeah, that's the controls textbook. Yeah, I think the controls textbook we've just recently passed 7,000 downloads, and I've
So
never seen a response.
How does that work? If somebody, engineering college in India, for example, wants to explore this controls textbook, what would they do to access it and use it?
Well, because since it's a mobile app, it's a mobile experience just on the Android store, the Play Store, or the Apple store, the App Store. You can just download it. Just search for Experience Controls or search for Quanser, and it's right there. You can download it and open it up, and that's it.
Okay.
Ready to go. Even on desktop, there are emulators that we've had a lot of experience with too that work quite well. If you prefer to use it on a laptop or something like that as well, it works quite well.
But this is a full one semester course or a module of a course?
Yeah, so it's a textbook. So it's meant to be kind of a reference, take the place of or augment a traditional controls textbook. So there's I think almost 40 different units that cover everything from the very basic introduction to control systems all the way through to very advanced topics, and each one has, again, starting with a motivation section and what the actual application, the motivation is behind learning about that particular topic, and then going through some of the grounding theories, but very quickly getting into, again, interacting with an example of that system industrially, whether it's a tank control system or an aircraft or even their own mobile device. We have a couple of modules that use the sensors on a mobile device. And be building out from there some check your understanding questions to make sure that the theory is hit home. We have end of chapter questions, again, to reinforce the understanding, but then in the instructor material, a whole lot of worked questions and solutions and PowerPoint slides. And like I said, for students, there's podcasts so they can listen to on their way to class, and just a whole experience built around reference content. The same.
Would you put up your email ID on one of the slides so that I can leave, and then Hans can jump in and say thank you.
Absolutely.
Remarks. You put up a slide with your email ID. Some people might have questions. I want to follow up.
Absolutely, no problem.
Hans, you're on.
Many thanks, Krishna. Peter, I just want to express on behalf of our IFES and GDC and IUCE global community our deep thanks to Quanser, working closely, of course, with Paul and all of you, and your very, very thoughtful presentation today. In particular, this whole question of motivation is fundamental. I loved it as a social scientist listening carefully to you. I just want to, those of us who are still on the call at this particular moment, just want to remind you that certainly in our continuing webinar series, we want to find ways to engage our students much more actively in a concrete way. And we'd love to, Krishna and I would love to explore with you, with Quanser, in terms of how we can move forward in partnership that we deeply value. An important part that the GDC is also focusing on is the facilitation of virtual internships. And this is not only between students in different universities, but also with companies. And again, that's an important topic. I just wanted to let the audience know that's of great importance to us. Another very important issue is working with women leaders in engineering, but also other fields, celebrating working with the World Federation of Engineering Organization, as also UNITAR, the UN agency with which we partner closely, 2 key events in early March. And we'll share that information of those webinars with our global community. I'm just very, very excited. And it's also partly linked to some incredibly creative work done by women leaders, engineering leaders in both Africa and India, where they're writing a new edition of our book series, Rising to the Top. I just want people to be aware of that. Finally, and certainly not last, is planting the seed again. We will meet not only the GDC in Germany and the industry forum in September of this year, hybrid virtual. We all want very much to see each other in person. And also in Madrid, I'd like to see students, faculty, deans, our corporate colleagues and friends in Madrid in November. And we are planning to have an exciting global event where hopefully we can see many of you in person, but certainly virtually. So again, on behalf of all of us, Peter, you're a very thoughtful presenter. Thank you kindly. Peace be with you and all of you. Please stay safe. Thank you kindly.
All right, thank you, and be happy, be safe, take care, everybody.
Bye-bye.